Question 5, I think it's coming from work, power, and energy. We can see a van of mass 2,500 kilograms traveling at a speed of V meters per second experiences a resistance force of kV squared newtons. The constant power of the van's engine is 62.5 kilowatts, but at the steady speed, this is constant speed, the steady speed that the van could maintain when moving along a straight horizontal road is 50 meters per second. Show that k is equal to 0.5 and find the acceleration of the van when its speed is 25 meters per second on this straight horizontal road. Okay, we have this van here. Okay, and then there is a driving force. Then it has a resistance force. Okay, the resistance force is kV squared. Now, they say that the steady speed that the van could maintain when moving along a straight road is 50 meters per second. Now, we know also that power is equal to the rate of doing work. Work is force times distance over the time, but distance over time is what? Velocity. Okay, so if distance over time is velocity, then we can have Fv. Are we there? Now, the F is going to be the driving force. So our driving force is therefore going to be equal to the power, which is given as 62.5 kilowatts. So 62500. So what are we given? We are given power, which is 62.5 kilowatts. Okay, and then our V is equal to what? 50 meters per second. So we shall divide this one by 50. And then what do we get here? 62500 divided by 50. It gives us 1250. 250 newtons. And then from there, you should know that for steady speed, acceleration is equal to 0. Okay, and using F, which is equal to ma, we have the driving force minus the resistance force. You see that? Then we shall equate that one to 0, because when you multiply here, that will be 0. Now, the driving force is 1250. I can take this on this other side, and then we have k, and then the speed that is given here is what? 25. 25? No, I'm going to use, because this one I will use it later. They said and find. Okay, so our speed is actually 50. And then we are squaring it. So meaning k is going to be equal to 1250 divided by, this is 2500. Then again, we are now going to find the acceleration. Now using, again, F is equal to ma. F is equal to ma. Now, since the speed has changed, okay, to 25, that means there is going to be a change in the driving force. You get it? So driving force is no longer going to be this one. So we shall get this one, then we divide by 25 instead of the what? The 50. So new driving force, shall be equal to, what will it be? 62500. Then we divide by 25. And of course, this one goes here 25 times. So we shall have 2500. Okay. Now, coming to this one here, we shall have 2500 minus kV. K is 0.5. V is now 25 squared. Then this one is equal to, the mass is 2500 of A. So meaning A is going to be equal to 2500 minus 0.5. 25 squared is the same as 625. Then we shall divide by 2500. That means our answer here is going to be equal to 2500 minus 0.5 times 625. Then down here we have 2500. The answer becomes 7 over 8, which is 0.875. 0.875 meters per second squared. As simple as that. Then next, they are saying the van begins to ascend a hill inclined at an angle of theta to the horizontal. The van travels along a line of greatest slope of the hill, and the speed of the van at the start of the hill is 20 meters per second. Its acceleration is 5a meters per second squared. Later on the same hill, the speed of the van is 30 meters per second, and its acceleration is a meters per second squared. The power of the van's engine remains at 62.5 kilowatts, and the resistance force remains at 0.5 V squared newtons. Part B, find the value of A and the value of theta. In mechanics, I've already said that you should have some art of sketching such that you know exactly what you're dealing with. Okay, now let me have, let's say, my van here. My van is here. It has a driving force, okay, and it has a resistance force which is 0.5 V squared. You see that? But there is also mg sine theta, so 2500 g, then sine of theta. Okay, that one has to be there. The horizontal component of the what? Of the weight. So if this is mg, this is theta. When you close up, this will be mg cosine, and then when you open up, then it becomes mg sine. Okay, then from there, what do we need? This one is going up, and the acceleration at this point, they said, is equal to 5a. Then the same van, I need this one. Okay, it's not going. So the same van is, let's say, at this point here. At this point here, its acceleration is a, okay, and the resistance force is this 0.5 V squared, and there is still the mg, okay, there is that mg sine theta still. You see that? Now at this point, the speed, they say, is 30. So 30 meters per second. And here, the initial one is 20 meters per second. You see that? Now I think I've put down whatever I need. Now, using Newton's laws of motion, we are going to use the F is equal to ma. F is equal to ma. So let's see what is happening here. Remember, power is equal to the driving force times the velocity, okay, or the speed. That means that the driving force then should be equal to power over the speed. So the driving force here is, the power is 62500, then divide by the speed, which is 20, okay, then minus the resistance forces. So we have 0.5, and then V, which V is what? 20. So times 20 squared, then minus mg, okay, mg, then sine of theta. You see that? Then this one will be equal to, mass of the van is 2500 times the acceleration is 5a. Now what do we get here altogether? 62500 out of 20, then minus 0.5 times 20 squared. This is 2925. Then this will be 25,000. And then we have sine theta. Then here 25 times 5 is 125. 125, then 2 zeros, and then the A. So I'll keep this one as equation 1. Then I also consider this point here. So we shall have also 62500, then divide by the speed is 30, remember here, then minus 0.5, then 30 squared, then this one will be equal to 2500, then times A. Oh, I think I've left out something. We shall also subtract 2500, the mg sine theta, then sine of theta, which is equal to 2500. The acceleration at that point is what? Is A. So what is this one simplified? 62500 out of 30, then we say minus 0.5 into 30 squared. So that is 4900. Just write it exact. Don't write decimals. This one is a recurring decimal. Always get used to using exact figures, and then you round off the final answer. Okay, then minus, this will be 2500 sine, no, there is another 0, then sine of theta, which is equal to 2500 of A. This is equation 2. Now I can solve these two simultaneously. So solving equation 1 and equation 2 simultaneously, I can see something common. This one here is common. That means when I subtract them, it disappears. Okay, so I'll get this one here, put it down here. Then I also get this one here. I'll put it here. So when I subtract them, then I'll get something here. So what is this one here? 2925 minus 4900 out of 3. That is 3875 over 3. 3875 over 3. Then this one will be equal to, what is this one here? The 2500 is going away. That means we have here 10,000 of A. So meaning A is going to be 3875 out of 3, then divide by the 10,000. This one can be all simplified to the answer which we got, then divide by 10,000. So we get 31 over 240. You can leave it as a fraction, or you can write it to 3 significant what? Figures. Okay, so that is that. Then we can substitute in any of the equations to get the value of theta. Okay, so suppose I use the first one here. So using the first one, we shall have 2925, then minus 12500 times A, which is 31 over 240. I've brought this one here, then I'm taking this one this side to be a positive. Okay, so this one will be equivalent to 25000 sine of theta. So meaning theta will be equal to the arc sine of, we are going to have the whole of this, then divide by that. Okay, so we have 2925 minus 12500 multiplied by 31 over 240. Then the whole of this we divide by 2005. no, 25,000. Okay, so what do we get here as the value of theta to 1 decimal place? Arc sine, the theta is in degrees, so make sure your calculator is in degrees. 2925, then minus, this will be 12500, multiplying 31 out of 240. Okay, then we close that, and then we go down. We are having 25000, and then we close the whole thing. The answer becomes a 3. So it is 3.0 degrees. That is to 1 decimal place. As simple as that. Question 6. The diagram shows the vertical cross-section ABC of a rough water slide. The section AB is a straight line of length 5 meters inclined at an angle of theta to the horizontal, where sine theta is equal to 0.8. The point B is 2.5 meters above the level C. There's the one here. A man of 80 kilograms modeled as a particle slides down the water slide, starting from rest at A. Okay, then the coefficient of friction between the man and the straight section of the rod is 0.1. Then part A, find the speed of the man at B. Now, they said that ABC is a rough slide, so there is frictional force. Now, if this man is here, who is taken as a particle, then, of course, this is the mg cosine of theta. Then this one here, remember mg is like that vertical, so the angle is in there. So we resolve, we put this one here, the mg goes there, and then we also put it here. So we have mg sine theta. So instead of actually writing m, I can just write 8. I think 80, because they said his mass is what? 80 kilograms. So this other one here, we shall also put 80 g sine of theta. Okay, there will be frictional force that acts in the opposite direction. There will be this r here. Okay, because the particle is on the plane. All right, now they said find the speed of the man at B. Now I'm going to, since there is cosine of theta, I will need to get the value of cosine of theta from this one here. Okay, now what are we going to do here? I'll create a triangle here. Okay, this is theta. 0.8 is the same as 4 over 8. So sine is opposite over hypotenuse. So this will be the 4, this will be the 5. And then this one here will be 5 squared minus 4 squared under the square root, which is going to be equal to what? 3. So sine of theta is equal to 4 over 5. And then the cosine of theta, it is going to be 3 over 5. Okay. Now, after that, this particle is going down. Okay. So I can say, using, let's say v squared is equal to u squared, then plus 2as. It is starting from rest, so we have 0 squared. We need to get the acceleration. Okay, so this is 2 times a here, then times the distance traveled. What is it from A to B is 5. You see it? From A to B. So that is 5. So times 5. So meaning A is going to be equal to v squared out of 2 times 5, that is 10. I can keep that. Now, using F is equal to ma, this force here is taking this particle downwards, okay? Then minus the resistance force, the frictional force. So we shall have 8g, then sine theta minus mu r, then is equal to 80 of A. So this will be 80 times 10 sine of theta, remember is 4 over 5 or 0.8. Then what else do we have? We have the coefficient of friction is 0.1, 0.1 here, then times r is equal to, there's no vertical motion here, perpendicular to the plane, so r is equal to 8g, then cosine of theta. So coming to this one here, we shall say 80, g is 10, cosine of theta is 3 over 5, which is the same as 0.6. And this one is equal to 80. And then our A is actually v squared over 10. Do you see that the only unknown we have here is v? Okay. Now, this is 800 times 0.8. Oh, this one will give us 8. So 8 times 80, that will be 640. And then, oh, how did I put equal signs here? This is a minus. Then minus, this will be 6. Okay, this one gives us a 6. Then this one will give us 8. So 6 times 8, isn't that 48? That is 48, which is equal to, of course, the 10 will reduce the 80 to 8. So meaning V will be equal to the square root of 640 minus 48 minus 48, then we divide by 8. So what will be our answer here? Square root of 640 minus 48, then out of 8, that is root of 74, which is 8.60. Okay, root of 74, which is 8.60 meters per second. As simple as that. Now, alternatively, we can use the energy method. Alternatively, using the energy method. Now, when I use the energy method, I'm supposed to look at the potential energy and then kinetic energy. So at this point here, there is this vertical height. Okay. So relative to this position, this particle here will have potential energy. Okay. Since it is starting from 0, there won't be kinetic energy. Okay. Because U is 0. Now, there is this H here. You see that? There is that H there. So there is this vertical height. So meaning that we are going to have a vertical height. You see that? Then, by the time it comes here, so this vertical height would have vanished. That means at this point here at B, we are only having kinetic energy. You see that? Okay. Now, using the work energy method, work energy principle, work done by the driving force minus work done against resistance is always equal to change in mechanical energy. And remember, we said that mechanical energy is always equal to the sum of kinetic energy and the gravitational potential energy. Okay. All right. Now, since this particle is just falling on itself, there is no applied force. The driving force that we are talking about is the one that you have applied on that particle and it goes with it. But this particle is falling by itself. It's a free fall. So don't think that this one is the driving force. No. Okay, so that means here we are going to have 0. Then work done by the resistance force. The resistance force is that mu r, the frictional force. And work done is equal to force times distance. The distance is 5 meters. You see that? Then this one is equal to final change in mechanical energy. We get final mechanical energy minus the initial mechanical energy. So this one will be the final in terms of kinetic energy, and this one will be the initial. So kinetic energy is given by a half, then m, which is 80, and then v squared, which v we are looking for, then minus potential energy is going to be mgh, not so? 80 times 10, then times the h. But what will be the h? So when we look at the h here, what do you think it is? Don't you think h is this 4? So if we have sine of theta, let me prove it for you here. We have sine of theta, which is equal to h out of the hypotenuse, which is 5. So when I cross multiply, that means our h is going to be equal to 5, then times sine of theta is 0. What? 8. So that is how h comes to be a what? A 4. So I'll have coefficient of friction is 0.1. Yes, then r, remember it is this one here, 8, 0, then times the 10. Then the cosine of theta, we saw up here that it is 0.6. 0.6. Okay, then we have a 5 here. Then this one is equal to, this will be 40 v squared, then minus, this will be 800 times our h, which is what? A 4. All right, now let's find v. Now let's find v. What is the whole of this? So we shall bring this one this other side. Okay, when I look at this one, we are having this one will give us an 8. Okay, this one will give us a 6. So 8 times 6, that one will give us 48. Then times 5. 48 times 5, that is 240. Now, when this one comes this side, it is 3200, then minus the 240, then we shall divide by 40, then after we take the square root, this one will give us v. Okay, so what will be the v here? 3200 minus 240, then when you divide by 40, do you get 74? 74. As simple as that, root of 74. So either way, you get the answer. It is given that there is no change in the speed of the man when passing through B, and that his speed at C is 11 meters per second. Find the work done against resistance force as the man moves from B to C. Now, when we go back here, I'll take this one here. Okay, that's what I'm going to be dealing with. So we have this curve part. Then this is C here. Since the speed here is 11 meters per second, then there is kinetic energy. I'm going to use the energy method. Now here there is a vertical height. This vertical height here is 2.5 meters. So because of this, then there is potential energy. And at this part here, at point B, okay, when this particle reaches here at B, it has a speed of root of what? 74. So meaning there is also kinetic what? Energy at point B. All right. Now, that is what I'm having there. Remember, there is what? Mu r here. Okay, so work done by the driving force minus work done against resistance is always equal to the change in mechanical energy. Now, work done by the driving force, I told you since it is a free fall, then it is 0. Then work done against resistance is actually the one they want. Okay, so WR then is equal to change in mechanical energy. The final is in terms of kinetic energy here. So a half times the mass is 80, then times 11 squared, then minus. Now the initial, I'm having these two here. Okay, so we have a half, then times 80, the kinetic energy. So we have root of 74, then we square. Remember the other value we got? Okay, then plus mgh. So m is 80, then times 10, and then the vertical height is actually this 2.5. Now, from here, we can be in position to get the value of work done. Okay, so what do we have here? Minus WR here is going to be equal to, this is 40 times 121, 40 times 11 squared. That one is 4840, 4840. Then minus, what do we have inside here altogether? 40, then times square root of 74, then you square, that one will give us a 74. Okay, so we shall put 74 here, and then plus, this will be 800, then times the 2.5. So altogether, that one gives us 4960. 4960. When we subtract these two, so minus WR is equal to 4840 minus 4960. That is negative 120. That means when you divide all through by the negative 1, you'll get your answer as 120 joules. Question 7 is coming from kinematics, but particularly from variable acceleration. And because we are having variable acceleration here, we are not supposed to use the other three equations of motion. V is equal to u plus at, s is equal to ut plus a half at squared, and then v squared is equal to u squared plus 2as. But instead here we use differentiation and integration, since we are given expressions for maybe displacement, velocity, or acceleration. Okay, so a particle x moves in a straight line. The displacement of x from O at t seconds after leaving O is s meters, where s is equal to 0.3 t squared plus 0.6 t for t ranging from 0 to 4. Part A, find the velocity of x. Now, we know that velocity is the rate of change of displacement. So, v is equal to ds dt. Now, when we differentiate here, remember you drop the power and then you reduce it by 1. So this will be 0.6 of t, then plus 0.6. And then for t, which is equal to 4, what will be our v? It is going to be 0.6, then times 4, which will be 2.4, then 2.4 plus 0.6, then the answer becomes a 3. So we have 3 meters per second, as simple as that. Then the next one, they are saying for t greater than 4, the acceleration of x at time t seconds after leaving O is a meters per second squared, where a is equal to 0.3 t to the power of a half. There is no change in the velocity at t is equal to 4. That means you are moving, and maybe when you reach here at t is equal to 4, it's the same speed, it's the same velocity that you are using for the next movement. You see that? Okay. The velocity of x at t is equal to capital T is equal to 14.2, and part B, Roman 1, they want us to find the value of t. Now, for t, which is greater than 4, they have told us that acceleration is equal to 0.3, then t to the power of what? A half. And then they have given us that velocity is equal to 14.2 meters per second at t, which is equal to at t, the small t, which is equal to capital T. Now, from here, velocity here is going to be equal to, remember, acceleration is the rate of change of velocity, so it will be dv dt. So meaning v is going to be the integral of acceleration with respect to what? To t. So we shall have the integral of 0.3, then t to the power of a half dt. And this one will give us 0.3, increase the power by 1, that will be 3 over 2, then over 3 over 2. And then we shall put a c here. Okay, so v here is going to be, what is this one simplified? 0.3 divided by 1.5. That is 1 over 5. So I'll have t power 3 over 2 out of 5, then plus c. You see? Now here I'm not going to say at t is equal to 0, okay? Because we are already in the new interval. So I will use, since there is no instantaneous change in velocity at t is equal to 4, so I'll take that one. At t is equal to 4, we know that our velocity is equal to what? 3, the one we got up here. All right, now substituting here, this implies that we have 3, which is equal to 4 power 3 over 2 over 5, then plus c. Square root of 4, that is a 2, then 2 cubed, this one will give us 8. Okay, so meaning c is equal to 3, then minus 8 over 5. So 5 times 3, that is 15, minus 8, that will be a 7, and over 5. So this means that the expression for v is going to be v is equal to t to the power of 3 over 2 out of 5, then plus 7 out of 5, or you can write 1.4. Okay, that is that. But then I said that v is equal to 14.2 at t is equal to t. Now substituting here, I will actually maybe bring this one here, just like this. And then we say this is 14.2, then it's equal to, where there is t, I put capital T, power 3 over 2 over 5, then plus 7 over 5. So I can multiply all through by 5. What is 14.2 times 5? 14.4 is a 70. 0.1 times 5, I mean 0.2 times 5, that is a 1. So that means this one will give me a 71. And then we have t to the power of 3 over t, then plus 7. So bring this one this side. We can have 71 minus 7. That will be a 64, which is equal to t to the power of 3 over 2. And then this means that t will be equal to 64, then power of 2 over 3. Okay, so our power 2 over 3, the reciprocal of this power, the same with this one here, such that this one can multiply and then it goes away. You see that? Then what do we have there? Cube root of 64 is going to be a 4. Then 4 squared becomes a 16. That means t is equal to 16. As simple as that. Roman 2, find the total distance traveled by x between t is equal to 0 and t is equal to t. Now, our distance, since v, okay, since v, I mean, yes, velocity is equal to rate of change of displacement, ds dt, that means s is going to be the integral of v, okay, v dt. But here, at first from 0 to 4, we are given the expression for s, so we don't need to get the expression for v, then we integrate. So we shall be just wasting time. So that means I'll get s, then I say this one is equal to 0.3 t squared, then plus 0.6 of t, okay? And we are putting limits from 0 to 4. I'm putting these modular signs because distance is a scalar quantity. Okay, suppose we were to draw a velocity time graph, you never know. One of the parts of this graph maybe is going to be above the t-axis, and then the other one is below. You get it? So you have to consider that time when t is equal to 0. So we consider this one alone and then this other one alone. Okay, then what else do we have? We also have now the integral from 4 to 16, and the expression for v, we saw that it is 3 over 2, then out of 5, t to the power of 3 over 2 over 5, then plus 7 over what? Over 5. Okay, now when you check here, they said that where a is equal to, there is no change in the velocity. So when t is equal to 4, the velocity at t is equal to this one, we have gotten the 16, this is 14.2. It is increasing, so it is just increasing. So I'm not going to consider that maybe v is equal to 0. Here it is just increasing. So from 4 to 16, what are we having here? Okay, so let's put the 4 in here. 0.4, 3 times 4 squared, then plus 0.6 times 4. Of course, when I put 0, that one will be 0. I will be saying minus 0, you see? Then plus this one here, when we integrate it, okay, we shall get t to the power of, increase the power by 1, so this will be 5 over 2. Then over, there is that 5 down, so times the 5 over 2. Then plus 7 over 5 of t. Okay, 16, 4. Even this one, I can put the modular signs just in case. Okay, this is 16 times 3, that is 48. So this is 4.8. And then plus this will be 2.4. 4.8 plus 2.4, that will be 7.2. Then plus this one simplified, this is 25 over 2, the 2 will somersault, and then we get 2 over 25 of t to the power of 5 over 2, and then plus 7 over 5 of t. Okay, then we put our limits. We have 16 and then a 4. So here this is 7.2, then plus, put a 16, 2 over 25, then 16 here, power 5 over t, and then plus 7 over 5 times 16. Then we shall subtract this 2 over 25, and then this is 4, power 5 over 2, then plus 7 over 5, then times the 4. Okay, and this one in the modulus. Okay, this is 7.2, then plus, what do we get here? 2 out of 25, then we have 16 power 5 over 2, then next minus, plus 7 over 7 times 16 here, then over 5. That one is 2608. 2608 out of 25. Then the other one, where there is 16, I can put 4. Put 4. So this is 204 over 25 minus 204 over 25. Of course, this one is bigger than this, so it is going to give us a positive value. So we have 7.2, then plus, what do we get here? 2608 minus 204. You get 2404. Then divide by 25. We get 96.16. 96.16. Add to 7.2. Then we get 103.36. 103.36 meters. I don't need to rate this one to 3 significant figures, okay, because it is a terminating one, decimal. So I will stop it there. So this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.